Hello, Professor. This is Bhavna Bullapalli, and my partner is Ruchi Reddy Kotla. This video is for the exploration of ICP8. Initially, in this ICP, we have done simple regression model and correlation, and we have plotted graphs for them respectively. We have for the ICP, we have imported necessary libraries like NumPy and Pandas, and we have imported visualization plot for MATLAB for plotting, and we have imported machine learning libraries like sklearn, and for linear regression we have imported linear regression and mean square error, and the data set is uploaded using files dot upload in Google in Colab, and we have read the data here. The content which we have take uploaded here is read here, and we have printed first five data, and we have taken the data size of the data using data.shape, and here we have taken the basic info of the data by using data.info, and the respective columns are displayed here, and here if we have any null values we have to remove the particular row, so that we are using data.drop in a function to remove the null values, and again we have to take the size of the data by using data.shape function. As there are no null values, the size of the data is not changed, it remains as previous. Here we are plotting the graph between dependent variables and independent variables. Like here we have taken a dependent variable fresh, and we have plotted it against grocery, electronics, and dairy, and this is how the this is how for correlation we are plotting the graphs, and for analysis of correlation we have taken a graph between two each and every variables, like furniture versus furniture, furniture versus grocery, and everything is plotted here. The respective values are shown here, and to build that is about the linear that is about correlation, and to build a linear regression model we need mean like y-intercept and slope and all. To find those values we have splitted the data into this particular values, and we have the taken shape of the x value, and we are converting the data from 1D to 2D here, where x is independent variable and y is dependent variable, and we are flattening the values of x and y values so that there won't be any irrational values like decimals which are not ending, irrational values, and we have flattened them here to get the precise values. And here this is a formula: y is equal to mx plus b, where m is slope, b is x intercept, b is y intercept, and here we are finding slope and y intercept by using these values, like by taking mean of x and y respectively, and we have printed the slope and y intercept here. This is the value of slope and y intercept, and we have we are finding the regression line for it, and we have plotted the regression line here. And to build a regression model we need a mean square error and some square error of the model, so that we can plot the linear regression model. To do that we are importing necessary libraries, and we are taking split the data into train and test data, and we are printing the shape of the respective x train, y train, and all everything here. The output is shown here, and we are taking the linear regression function to create linear regression model, and we are training the data using we are training the model using the training sets, and we are taking in linear regression model we need to predict the values by using we need to predict the value of something using other, so that for that we are taking ypred, and we are using model.ypred predict to predict the value. And we are finding mean square error by using the particular function by passing y test and y predict. And we are finding the mean square value and sum square value respectively, and the output is shown here. We have printed the output here of sum and mean. And here we are plotting the regression, I mean linear regression model by using x label by taking x label, y label as furniture and bath body respectively, and here the output is shown. This is how the linear regression model is done. Thank you.